This lesson is on the applications of the Pythagorean theorem in 3D spaces or three-dimensional spaces. So looking at this first problem at the top, Lindsay wants to mail a candle that is 8 inches tall to a friend for her birthday and needs to know if the candle will fit diagonally in a box with the dimensions shown. So if I look at this box diagram on the right, I've got a length of 4 inches, a width of 3 inches, and a height of 7 inches. Obviously, the candle is not going to fit straight up and down, but it might fit diagonally. So what we're going to do is we are going to look at how we can find this diagonal length. One way we can do that without having to memorize the formula for a 3D diagonal is to use the Pythagorean theorem, but it's multiple steps. If I use these 3 points, I'm creating a right triangle, but I have to be able to find the legs of that right triangle in order to find the diagonal. In order to find this bottom leg, I would need to use the Pythagorean theorem to find the diagonal of the base, the bottom side of the box. The diagonal bottom side of the box then becomes that line that stretches across. So 3, 4, and 5 are a Pythagorean triple, but 3 squared plus 4 squared equals c squared. And of course, the square root of 25 is 5. So this piece would be 5. I know that the height is 7, so this needs to be 7. Now I've created myself a right triangle with 7, 5, and a missing c, which would be that 3D diagonal. What I can do is 5 squared plus 7 squared equals c squared. So that's going to give me 74. So that would be 8.6. The other way I can solve for this is to use the formula. If I have a rectangular prism, it would be that the diagonal squared equals the length squared plus the width squared plus the height squared. And I would just plug in each value and then take the square root when I'm solving. So I know the diagonal is what I'm missing. My length was 4 inches. My width was 3 inches. My height was 7 inches. What that gives me is d squared equals 74. The opposite of squaring is to take the square root. So I get that the diagonal equals 8.6. Both times we got 8.6 for our final answer for our diagonal. The question asks us if the candle will fit. Well, the candle is 8 inches tall. The diagonal is 8.6 inches. So yes, the candle will fit because the candle's height is less than the diagonal. Now let's look at some other examples. Just like before, I can use the Pythagorean theorem if I want to create a right triangle with the diagonal of the base, the 3D diagonal, and the height of the box. Or I can use the formula, which again is d squared equals L squared plus W squared plus H squared. It'll give me the same thing no matter which method I choose. I'm going to go ahead and use the formula for this one. So d squared, I know that my length is 13, my width is 6, and my height is also 13. When I add those up, I'm left with d squared equals 374. I'm going to take that square root, and d equals, or the diagonal equals, about 19.3 inches. Remember, the direction said to round to the nearest tenth. This is a great opportunity for you to pause the video and try the second one on your own, just to make sure that you've got the concept down. All right, let's look at this second example. So I've got my missing diagonal. Again, that formula is diagonal squared equals length squared plus width squared plus height squared. So that missing diagonal squared equals the length squared plus the width squared plus the height squared. When those are added together, we get that d squared equals 865. Our last step is to take that square root, and our diagonal is about 29.4 inches. So as long as you can memorize that formula, finding the diagonal is not incredibly difficult. If it's easier for you to visualize using the Pythagorean theorem, just imagine that diagonal stretching across the base. Just remember, you would have to use the Pythagorean theorem to find this piece here that stretches across the base of that box. All right, in this third example, we've got a multi-step problem, it looks like. And the prism shown, AC, is 12 centimeters. And I'm going to go ahead and mark as I go. So AC is 12 centimeters. CD is 5 centimeters. And BD is 2 centimeters. Mark each statement as true or false. If false, rewrite the statement correctly. This first statement says that the length of AD, which would be across the bottom of the box, diagonally across, is the square root of the sum of 12 squared and 2 squared. So what they're saying is that we would use 12 squared plus 2 squared equals c squared to find that. But that 2 doesn't have anything to do with the bottom of the box. So instead, it would be 12 squared and 5 squared. So this is false. And instead of 2 squared, it would be 5 squared. So we would add 144 and 25, which would give us 169. When we took the square root, we'd get 13. So I know that that distance AD is 13. The next statement says that AB, this 3D diagonal, is equal to AD. Well, we know that AD is 13. Let's see about AB. I know that AB is that 3D diagonal. So length squared plus width squared plus height squared. Well, I know that the square root of 173 is not going to be equal to the square root of 169 or to 13. So I know that this is also false. And that instead of equal, AB will be greater than AD. Now let's look at the way we might see a 3D diagonal in a cone or in a pyramid. So we know that the height of a pyramid or cone will always be perpendicular to the base. This means that it intersects the base at a right angle. or a 90-degree angle. In a pyramid, the slant height is the lateral distance from the vertex to the pyramid base. So this here is the slant height. While the inside is just referred to as the height. And we can see how that helps us create a right triangle. The slant height also intersects the edge of the base at a right or 90-degree angle. So another way to look at that is that we'll create a right triangle on the surface of the pyramid as well, not just on the cross section inside it. So using the slant height and the actual height, we're creating two right triangles, one that exists inside the 3D space, if we're thinking of it as like an open space, and one that exists on the surface. Now let's look at some examples. The radius of a cone is 14 centimeters. I know that the radius is the distance it takes to get halfway across a circle. The entire distance would be the diameter. So they gave me the radius, so I know that goes from here to here, and that's 14. The slant height, or the height on the outside, is 28 centimeters. And they're asking me for the height, or this inside height of the cone. So I've used the slant height the radius and the height to make a right triangle. Now, let's zoom in on that picture a little bit. I know that the legs of a triangle come together to form the right angle. So that would be the height and the radius. The slant height is across from the right angle and will be the hypotenuse. So now we can use the Pythagorean theorem, or a squared plus b squared equals c squared, to help us. So a squared is 14 squared. We don't know b squared, and c is 28. We can rearrange it to look like this. Since we're finding a leg, we're going to subtract. So this becomes 784 minus 196, or 588. My last step is to take that square root. And I get approximately 24.2 if I'm rounding to the nearest tenth. The next example gives us a pyramid. The base of the pyramid is a square with side lengths of 30 inches. The height of the pyramid is 50 inches. Find the slant height. Now remember that slant height is the height on the surface of the pyramid. Now, if I look closely at this picture, I'm actually missing two lengths. I'm missing the hypotenuse, or the slant height, but I'm also missing this bottom leg. I know that the stretch across the entire side length is 30. The height drops down right in the middle, so I know that this last leg, or this bottom leg, has to be 15. Because I'm finding the hypotenuse, I'm going to add a squared plus b squared equals c squared. When I use the Pythagorean theorem, I end up with the square root of 2,725, which is approximately 52.2. Now that we've done some examples, I want you to try example 6 and 7 on your own. Now remember, radius is half of the diameter on a cone. All right, looking at example 6, the diameter of this cone is 40, which means that the radius is 20. The height is 21, and we are looking for the slant height or the hypotenuse. So when I set this up, I'm going to add when I take the square root of 841, I get that that slant height is going to be 29 feet. This last one is a little bit of a multi-step problem. A window washer is repelling and cleaning the windows of a hotel shaped like the square pyramid shown. The height of the pyramid is 200 feet. If the window washer travels to the top of the pyramid and back down along the straight path X, or the slant height, how many total feet has he traveled? So first, let's think about the path that the window washer is going to have to take. He's going to walk in the door, climb to the top, and rappel down, and repeat the process to wash the windows. So we know that this total distance is 300, which makes this distance 150. So when I find that slant height or the hypotenuse, c squared, or in this case x squared, and take that square root, I get that the slant height is 250 feet. But the question didn't ask me about the slant height. This question asked me that if he travels to the top of the pyramid, back down along the straight path X, how many feet has he traveled? Well, if he walks in, up, and down, that means I have to add all of those distances together. So he's gone 600 feet.